If you really fell into a black hole, what would you see? A black hole, this ultimate mystery, which scientists have studied for decades, and which has fascinated countless people. What exactly is hidden inside it? Is it nothingness, a bottomless abyss, or some kind of gateway to a parallel universe? Honestly, we still don't have a definite answer, but scientists have already proposed some very serious and very crazy hypotheses. Don't rush to conclusions yet. Why not hear what they have to say? Imagine that, deep in the vast universe, there is a supermassive star, shining like a diamond. But even the brightest star will one day burn out, when its nuclear fuel is completely exhausted and the force supporting it disappears. The entire star will collapse inward in an instant, not explode outward, but be crushed by its own gravity. How extreme is this collapse? It punches a bottomless pit into the universe, as if space-time itself has been pierced. That pit is a black hole. A true no-escape zone, where even light cannot get away. A black hole itself emits no light, but as you approach it, you would see an absolutely breathtaking scene. The surrounding gas and dust are violently pulled, accelerated, and spun into a blazing accretion disk, like a flaming carousel in the universe. The temperature here can reach millions of degrees, constantly releasing X-rays and high-energy radiation, which can even be detected by telescopes on Earth. To be honest, humans could never survive in such an environment. But let's assume for a moment that you somehow survived and kept moving closer. You would encounter an invisible yet unavoidable boundary. And this is the event horizon. It is not a wall, but it is an absolute dividing line. Once you cross it, no matter how hard you struggle, you can never turn back. Even if you floor the engines, you would only be spinning your wheels in place, because from here on, even light cannot escape. When you truly fall into a black hole, everything around you starts to become more and more bizarre. According to Einstein's theory, space and time are not separate. They are woven together into a structure called space-time. You can imagine it as a giant elastic sheet. Ordinary objects placed on it make only a slight dip, but the extreme mass of a black hole drags that sheet almost to the point of tearing. As you approach a black hole, it is like being pulled into a space-time whirlpool. For example, light gets bent, twisted, and stretched. Colors keep warping, direction loses meaning, and the whole world looks like a cosmic funhouse mirror. You might even feel an illusion, as if you were walking backward through space, yet never touching the ground. Even worse is time. Near a black hole, time does not flow evenly. The closer you are, the slower time moves. For you, maybe only a few minutes pass, but for the distant universe, decades or even longer may have gone by. You are still falling, while the outside world has already been completely transformed. The deeper you fall, the stranger things become. You would find that the familiar laws of physics are breaking down one by one before your eyes, as if the universe's instruction manual were being torn to pieces on the spot. But suppose you somehow miraculously endured all of this, without being stretched apart, without being torn apart, then the question is, where exactly are you falling to? As you continue descending into the deepest part of this cosmic vortex, you would arrive at an extremely mysterious place. The singularity, it is the core of the black hole, the final endpoint where all matter and energy are compressed to the limit. Imagine taking the mass of an entire star and crushing it into a point almost as small as the tip of a needle. From this moment on, don't expect any physics you are familiar with to be of any use. Welcome to a whole new realm, where the known completely collapses and the unknown takes over. So what does that unknown actually look like? Scientists have proposed several bold, almost insane ideas. The first view holds that the inside of a black hole may be an entrance to other dimensions. What if there is more than one universe? What if every black hole contains another universe, nested one inside another like Russian doll? In this theory, the interior of a black hole may connect to a parallel world with completely different physical laws. A reality entirely unlike our universe, utterly unfamiliar. Just thinking about it is enough to make your scalp tingle. There is another hypothesis you may be more familiar with: wormholes. Imagine black holes as a kind of cosmic subway system, quietly linking different regions of space-time together. Extreme gravity might tear open a tunnel, sending you instantly to a distant galaxy, or even straight into the past or future. It is like suddenly finding a hidden passage in a game, except this time, the price may be an entire timeline. More radical scientists believe that some kind of exotic matter may exist inside black holes. This matter might have completely abnormal properties, such as negative energy density. If that were ever confirmed, it would directly overturn everything we think we know about the universe. The wildest, most shocking idea of all is that the end of a black hole may not be swallowing, but eruption. In other words, a black hole might lead to something called a white hole. Imagine continuing to fall downward, when suddenly the surrounding scene changes dramatically and the darkness is torn open. In its place is a blinding white light. It would feel as though you had been flung into a completely new space. Maybe you have entered a white hole. A white hole is like an out-of-control fountain, violently spewing out matter, energy, and even information itself, and it is thought to possibly be the birthplace of a new universe. We know the black hole's event horizon. Once crossed, nothing can escape, but a white hole is thought to have a reverse event horizon. In a black hole, everything can go in, but nothing can come out. In a white hole, the situation is exactly the opposite. It repels everything. Nothing can get in, only be pushed out. White holes are still hypothetical objects, and whether they really exist has never been confirmed. But if they do exist, they're likely closely related to black holes. This idea is actually quite reasonable. Black holes constantly swallow matter and energy, and all those vanished things must end up somewhere. Maybe they are released again through white holes. All the matter and energy erupting from a white hole might even give rise to entirely new universes. In that case, black holes and white holes together would form a cosmic cycle, where the end of one universe may be the birth of another. These theories sound elegant and astonishing, but the problem is very real. At present, we have no conclusive evidence proving that any of them are true. Black holes remain one of the most mysterious and hardest to understand things in human knowledge, and studying them is itself an extremely difficult task. The reason is simple. Black holes do not emit light. They are almost completely invisible. Traditional telescopes that rely on light-based imaging simply cannot see them directly. Scientists can only study them indirectly, by observing X-rays and radiation, analyzing their gravitational effects on nearby celestial bodies, or tracking the abnormal motion of nearby matter. Even trickier, black holes are extremely unpredictable. There, space and time are warped so violently that the laws of physics seem like a piece of rubber being stretched at will. For black holes, physics is more like a playground where all the rules have been completely scrambled, which makes it very hard for scientists to build stable, reliable models to understand how they behave. But don't lose heart, space enthusiasts. The good news is that the future of black hole research is still full of hope. In 2019, humanity captured the first real image of a black hole, the supermassive black hole, at the center of the M87 galaxy. A few years later, we successfully imaged the black hole at the center of our own Milky Way, Sagittarius A*. These achievements opened a whole new door for black hole research. And that is not all. The discovery of gravitational waves was equally significant. Just as a stone falling into water creates ripples, gravitational waves are ripples in spacetime itself. They record the most violent and catastrophic events in the universe, allowing us for the first time to hear the universe and capture phenomena that were once completely hidden. These methods of observation have opened an entirely new path for black hole research. As technology continues to advance, instruments like the James Webb Space Telescope will bring us more details and clues about black holes. We still know far too little about black holes, but that is exactly what makes science so fascinating. OW2ORD, the unknown, and the endless desire to explore the mysteries of the universe. So let us keep staring into that cosmic abyss, step by step, moving closer to the answer on the journey toward the truth. Now imagine this scene. You are traveling through space, and ahead lies an unusually dangerous region. You must avoid asteroids, cosmic debris, and even black holes. It sounds like the plot of a science fiction drama, but this time, it is not entirely fantasy. Scientists have discovered, for the first time, a completely solitary black hole. It has no star, no planet, and drifts alone through the universe. This black hole is about 5,000 light-years away from us. Located within the Milky Way, do we need superheroes to save Earth? Don't panic yet. First, let's understand what it is. A black hole is a region whose gravity is so strong that even light cannot escape. The reason its gravity is so terrifying is that an enormous amount of matter is compressed into an extremely small space. Generally speaking, supermassive black holes tend to sit at the centers of galaxies, with masses hundreds of thousands or even billions of times that of the Sun, and they are usually relatively quiet, hardly moving at all. But this newly discovered black hole is anything but ordinary. First of all, it refuses the spotlight. It has no companion star and belongs to no stellar system. Even crazier, it is racing through the universe at about 50 kilometers per second. At that speed, what exactly happened to it? Scientists have proposed one possible scenario. Long ago, an extremely massive star exploded as a supernova, and that star was the precursor of this black hole. The enormous recoil from the explosion was like a violent kick, sending the newborn black hole flying and starting its lonely journey across the galaxy. This is only one of many explanations, but it sounds fairly plausible. At this point, you may be wondering, if this rogue black hole ever wandered into the solar system, would we be finished? Scientists give a simple answer: relax and take a deep breath. It is extremely, extremely far away, and almost certainly will never come near Earth. And right now, it is very quiet, neither glowing nor devouring anything. Only when it begins feeding on surrounding matter would it really light up. In the future, as more powerful observational instruments come online, scientists are likely to discover more rogue black holes like this one. Normally, black holes are extremely hard to detect because they do not emit light. We can usually confirm their existence only in two situations. One is when a black hole is swallowing nearby matter. The gas falling into it is heated to extremely high temperatures and emits bright light. The other is when a black hole has a companion star, whose abnormal motion indirectly reveals the black hole's presence. But this black hole is completely different. It is a total lone wolf. No light, no companion star, and no violent activity of any kind. So the question is, how did scientists discover this cosmic drifter at all? The answer is a phenomenon called gravitational microlensing. When a black hole passes in front of a distant star, its powerful gravity bends and magnifies the star's light, just like looking through a magnifying glass. It was precisely through this method that scientists, despite the black hole being completely invisible, successfully identified its existence. Overall, black holes are already mysterious enough on their own, but some of them can truly be described as monster-level objects. Nearly every galaxy has a supermassive black hole at its center, usually with a mass millions to billions of times greater than the Sun. One of the most outrageous examples is called TON 618. It is an incredibly enormous and powerful black hole, belonging to a class of objects known as quasars, which release astonishing amounts of energy. TON 618 is about 18.2 billion light-years from Earth, with a mass around 40 billion times that of the Sun, making it one of the largest black holes currently known. Even crazier, black holes do not just swallow stars and gas. Sometimes they do not spare other black holes either. Scientists have directly observed a huge black hole at the center of one galaxy being completely swallowed by an even larger black hole. This was the first time humans directly captured the process of one black hole eating another. This discovery came from NASA's Chandra X-ray Observatory. One of the black holes had a mass around 30 million times that of the Sun, while the other was at least 1 million solar masses. There is another, even more extreme kind of black hole, known as a black hole that fires. You might think black holes only swallow things, but in fact, they can also violently shoot matter back out. Astronomers once studied a relatively small black hole, about 28,000 light-years from Earth, with a mass only 5 to 10 times that of the Sun. They observed that this black hole was tearing matter away from its companion star, and some of that matter was not swallowed. Instead, it was blasted out at high speed in the form of giant gas bullets. How fast were these jets? Close to a quarter of the speed of light, almost like high-speed weapons of the cosmos. Some black holes also spin at absurd speeds, so fast that they drag the surrounding spacetime itself into rotation. For example, there is a black hole in the constellation Aquila, about 35,000 light-years from Earth. Its rotation speed exceeds 950 revolutions per second. If you could place an object at the edge of its event horizon, it would orbit the black hole at about 536 million kilometers per hour, nearly half the speed of light, and one of the smallest black holes discovered so far has been nicknamed the unicorn by scientists. It is about 1,500 light-years from Earth, with a mass only about 3 times that of the Sun, very close to the theoretical lower limit at which a black hole can stably exist. Although black holes are extremely far away from us, and nearly impossible to observe directly, scientists have still devised many ingenious methods, and have even simulated some of their properties here on Earth. For example, the intense gravity of a black hole ensures that once anything crosses the event horizon, it cannot escape. To better understand this, researchers used fiber optic systems to create an artificial event horizon in the laboratory, even successfully simulated a phenomenon similar to Hawking radiation, the faint energy that theoretically may escape from a black hole. These black hole-like systems in laboratories are helping scientists inch closer to the true physical nature of real black holes. In fact, black holes do not come in just one type, and they are born in different ways as well. Primordial black holes are thought to have formed shortly after the Big Bang, when the universe was still extremely young. Stellar mass black holes come from the death of a massive star. When the stellar core collapses and triggers a supernova explosion, the outer layers are blasted away, while the core collapses into a black hole. As for supermassive black holes, they are believed to have grown alongside galaxies. During the early stages of galaxy formation, their size and mass are often closely linked to the scale of those galaxies. Unlike what many people imagine, black holes do not wander around the universe, actively hunting for planets to devour. They follow the laws of gravity too. Just like other celestial bodies in the universe, to have any effect on Earth, a black hole would have to come very, very close. And currently no black hole is anywhere near that close. Even if a black hole with exactly the same mass as the Sun directly replaced the Sun, Earth would not immediately fall into it, because its gravity would be the same as the Sun's. Earth would still orbit it just as it does now. Of course, the temperature would drop drastically, and humans certainly could not survive. But that would be a different problem. Still, you do not need to worry. The Sun can never become a black hole. It simply does not have enough mass. In about 5 billion years, when the Sun reaches the end of its life, it will first expand into a red giant, then shed its outer layers, forming a glowing ring of gas, what we call a planetary nebula. And what remains in the end will simply be a white dwarf that gradually cools down